Yeah, hello. Yes, we welcome you back to our channel, Natural Sciences, Grade 8 and 9, with me, Richard here. Yes, today we are looking at this case. It says that troposphere is the lowest layer in the atmosphere. It is 9 kilometers at the pole and about 17 kilometers at the equator from the sea level. Okay. Then what factor is responsible for the difference in thickness of troposphere between the pole and equator? Yes, we have noticed that the thickness is not uniform. At the pole, it's 9 kilometers, and at the equator, it is 17 kilometers. Now the question is, what is responsible for that difference? Okay. The cause is the rotation of the earth. It creates forces which disperse the atmosphere unevenly. Yeah, as you progress, you'll see those forces. We call them centripetal forces. So generally, it is the rotation of the earth which is causing that. Yeah, that is that. So the factor is rotation of the earth. Yeah. Then we come to this question. It says that the bottom part of troposphere has high enough density for us to afford breathing. And the question says, state what happens to each of the factors below as you move away from the surface of the earth. Yeah, what happens to each of these factors? The first one is density of troposphere. What happens to it as you move away from the earth's surface? The answer is it decreases. Yeah, gradually. Then we come to temperature. What happens to the temperature of troposphere as you move away from the earth's surface? What happens? It decreases as well. Yeah, then we come to this one, oxygen level. So what happens to oxygen level of troposphere as you move away from the surface of the earth? It decreases as well. It decreases until it reaches the stratosphere. Yeah, that is it. Yeah, then we come to this case. All the weather systems take place close to the earth in the troposphere. The air in the troposphere is in constant motion, creating clouds and cyclones. And then the question says, briefly explain what makes the air in troposphere to be in constant motion. Yeah, briefly, this is what you have to know, that whatever weather patterns you see, the rain coming, the cyclone, and that intense wind, all of them are taking place close to the earth here, in this sphere, troposphere. As you go up there, air is still not changing. And the question is, why is it close to the earth? What is creating this motion of air? So the question says, briefly explain what makes the air in troposphere to be in constant motion. Okay, the answer lies from the fact that the earth sometimes becomes warm. So what happens to the warm earth? It hits the air above it, and when the air is heated, it becomes less dense. So when air becomes less dense, what happens to it? It goes up, and its position is replaced by cooler air. So that convection movement is what creates all we see as the clouds, the cyclones. Yes, it comes from the fact that the earth is warm, so it warms the air above it, causing convection currents. Yeah, that is it. The warm earth warms the air, and this makes the warm air yeah, that is it. The warm earth warms the air, and this makes the warm air to rise and its place taken up by cold air. This movement creates convection current, which form the clouds and cyclones. Yeah, then we come to this question. It says that the temperature of the troposphere decreases steadily until it reaches about negative 60 degrees Celsius at the distance of 10 to 12 kilometers above the sea level. Then it stabilizes before it increases again. Yes, that one is called the temperature inversion. Temperature decreases as you go up. When it reaches this height, which is 10 to 12 kilometers, it becomes steady, not increasing, not decreasing. But after that, temperature increases again. That's why we call it inversion, because it changed the pattern in which it was going. It was decreasing, now it's increasing. Then this comes. This region, when temperature stabilizes, represents the transition zone between troposphere and the stratosphere. Okay, then the question says, explain the importance of this zone in determining the environment of the earth. Yes, why is this zone, the transition zone, very important? Okay, what does it do? It forms a barrier which prevents the escape of heat and moisture into the upper space. So it protects the heat from the environment from escaping. And as a result, it makes the earth warmer. Yeah, that is it. Forms a barrier, preventing warmer, moist air from escaping from the troposphere. Yeah, then we come to this question. It says that beyond this stabilization zone, there is no weather patterns. Yeah, then we come to this question. It says that beyond this stabilization zone, there is no weather patterns. And the question says, explain. Yes, after stabilization zone, we don't have the cyclones, we don't have this um, gasping wind. Yes. The reason is that air beyond that does not circulate. It is still. We have to be reminded that it's the convection current which are responsible for all the weather patterns we see in the troposphere. So beyond that, air is still. It is not circulating. Yeah, that is that. And with that, I would like to thank you for your time. The channel is Natural Sciences Grade 8 and 9. With me, Richard, here. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. Yeah, see you next time. Bye bye.